Just when you thought the world of black holes couldn't get any more bizarre, Professor Hawking has claimed the destructive chasms may contain coatings of what he has called soft electric hair. Last year, the physicist revealed black holes were not the eternal prisons many think them to be, and it is possible for data to escape from the abyss. The 74-year-old has now expanded this theory in a recently published scientific paper, and said the answer lies in the zero-energy particles, or soft hair, that sit on the black hole's horizon. The long-awaited theoretical calculations behind the theory have been published in the paper Soft Hair on Black Holes, on AR14. The paper seeks to tighten up the rules regarding how information can escape from the clutches of oblivion by providing concrete tools to address what's known as the information paradox. Speaking to scientists in Stockholm in August, Professor Hawking teased the theory when he explained that black holes may not be so black after all. He challenged the assumption that anything sucked into the massive objects is lost forever. In particular, the theoretical physicist claimed to have discovered a mechanism by which information is returned out of the black hole. In fact, his theory suggested information lost in black holes could even be stored in alternative universes. During his presentation, Professor Hawking talked about finding a solution to what happens to the information about the physical state of things that are swallowed up by black holes. The laws of quantum mechanics demand that it should be retrievable, but that presents a paradox for our current understanding of black holes. This has been an outstanding problem in theoretical physics for the last 40 years, no satisfactory resolution has been advanced, Professor Hawking said. I propose that the information is stored not in the interior of the black hole as one might expect, but on its boundary, the event horizon. This is the casing of a black hole and the point at which matter is drawn into its center. Professor Hawking explained, the answer I propose is that the information is stored in a super-translation of the horizon that the ingoing particles caused. The information about ingoing particles is returned, but in a chaotic and useless form. For all practical purposes the information is lost. The theoretical physicist likened the return of information to a burned encyclopedia, where information wouldn't technically be lost, but would be incredibly hard to decipher. Instead, a translation of the scrambled information would create a hologram of original particles, and the radiation leaving the black hole would carry some of the information stored on the event horizon with it. The scientific paper detailing his theory now expands on this. It states that the particles that sit on the event horizon would consist of photons and gravitons, which are subatomic packets of light and gravitational energy. These very low, or even zero energy, quantum particles deposited on the edge of the black hole, can capture and store information stripped from the particles falling into the black hole. This effectively means that while the particles falling into the black hole may be gone, their information continues to linger at the edge of oblivion in this soft hair of quantum particles. This has been likened to the way nose hairs catch dust, for example. According to the hologram theory, these particles are pixels in the hologram which store the information. In an interview with Scientific American, one of the CO authors and a theoretical physicist at Harvard University, Professor Andrew Strominger said, "We show that when a particle goes in, it adds a soft photon to the black hole. So it adds hair to the black hole. And more generally if particle goes in, because all particles carry mass and are coupled to gravity they always add a soft graviton. So there's a kind of recording device. These soft photons and gravitons record information about what went into the black hole. Infinitely more information than we previously believed is recorded by this mechanism. The existence of alternative histories with black holes suggests this might be possible," Professor Hawking added. He said the hole would need to be large and if it was rotating it might have a passage to another universe. But you couldn't come back to our universe. So although I'm keen on space flight, I'm not going to try that, he quipped. However, despite these new calculations, a full understanding of exactly how the holographic plate might work may still be some way off. The authors wrote, "A complete description of the holographic plate and resolution of the information paradox remains an open challenge, which we have presented new and concrete tools to address."